Hi, this is Dr. Liu. In this video, we'll cover the basic definitions of kinematics, that is position, displacement, velocity, and acceleration. So let's start with position. We use x as a symbol for position, and we normally use meters for units. So nothing to say about position except that we need a one-dimensional coordinate system, right? So it'll have its origin, and also there's let me grab a ruler. There's going to be an axis, and also there's going to be some scales, such as here's 1, 2, 3, 4, 5, right? So, and we'll call this x. So in order to describe position, you need an origin and the direction, which you call positive, and then you also want to know the scales, right? So that is what we need to know about positions. So let's move on to displacement. Displacement is change in position. So we call it delta x. This delta. Okay, so delta x, and it is defined. I use these three lines equivalence as a definition when I bring up a new concept. I'll use that as position later minus position earlier. You may also recognize this as x final minus x zero or x final minus x initial. I'm using the 2 minus 1 notation. So it is just a change in position, and that naturally carries the same unit, right, in meters. So we could have, say, a positive displacement. Say if x1 is here and x2 is here, so here's a positive displacement because you displace it right. But if you have x1 here and x2 are here, I'm basically using the same coordinate system, and this way is a negative displacement, right? It's delta x less than 0 because your final position is less than your initial position, and this delta x is greater than 0. This is regardless where the origin is. Your origin could be way to the right side, and it is correct that you go forward in the x direction, you have positive displacement. You go negative backward along the x direction, you have negative displacement. The origin doesn't matter. It could be here, it could be way over here, it could be somewhere in the middle. As long as you displace negative in the direction of your x, you have negative displacement. If you displace positive along the direction of your x, regardless where you start or where you end, you have a positive displacement. So this displacement is a useful intermediate step to calculate or define velocity. So let's do an actual example, such as x1 equals 3, x2 equals 7. So then delta x is x2 minus x1, the final minus the initial, which is 4. So 4 meters of displacement. So in this case, it is a positive displacement. So let's move on to velocity. This is the average velocity, by the way. So we use, well, let's maybe move that here. V for velocity. The unit is meters per second. And how do we define average velocity? So average velocity, V, is defined as delta x over delta t. So what exactly is this? Well, let's do this. Let's move this down a little so we have space to explain. Okay, so let's move it down about here. Okay, so that is delta x is x2 minus x1, or x final minus x initial. And then delta t by the same token is the later time, a final time minus initial time. So we have t2 minus t1, could also be t final minus t naught, 0, or t final minus t initial. So the top is displacement in position, the bottom can be called displacement in time if you want. So let's have an example to calculate this average velocity. So we'll have an example. This was an example here. We'll have the same exact setup. X initial is 3, x final is 7, but we also are supplying t initial, say 1 second, t final 3 seconds. So from here we can calculate the delta t to be 3 minus 1, 2 seconds, right? 4. So V average is final minus initial, so 7 minus 3 divided by 3 minus 1, so 4 over 2, that gives you 2 meters per second of average velocity. This average velocity describes the duration between 1 second and 2 seconds. Let's calculate an average velocity that is negative. For example, at the same time this object is moving from 3 to 7, another object is actually moving also. It's moving on from 3 to 1. So kind of two objects parting their ways. All right. So the next one we have x1 equals 3, x2 is equal to 1, and the same t1 and t2. All right. So let's move this whole thing down halfway, so we have space for this, and we'll actually be doing the same thing, V average. So now we have a final is 1, initial is a 3, and time-wise, final minus initial. Time is usually running forward, right? So this bottom is usually a positive quantity. Okay, so we have a minus 2 over 2. So we have a minus 1 meter per second. So if you displace negatively, that will give you a negative displacement, because time displacement is usually positive. Then with a negative displacement, you have a negative velocity, which means you travel negatively along the x direction. So you travel against the x direction this way. Doesn't really tell you where you start, where you end, because you have kind of subtracted them away to just get the change, right? So positive velocity is traveling along the x, negative velocity traveling against the x. Doesn't say anything about exactly where you start traveling. Okay, so let's now move to a different way to define average velocity. So we encounter this very often. Say we're just driving to a location, say from St. Cloud area to the Twin Cities. We need to drive on the highway for over an hour, depending on where you're going, and then you get out of the highway, drive on local road for some time before you get to your destination. So you have these multiple legs of trips, and what would be your total, your average speed, average, or you can also call it average velocity in this trip. I think you can easily understand this is how much time you took, right, and how far you traveled. So the total travel distance over total time, that gives you the average speed. So let's do this average. And sometimes we call it velocity, because we're thinking that we're traveling in more or less a linear fashion, only forward. Although we're taking turns, we're not really double backing, so we're just traveling in one particular fashion. So from say speed and time. So I'll just set up a simple example here. Say we're traveling at 50 miles per hour for 4 hours. Okay, so how far can we get 4 hours? It depends on which way we're driving. I think if we're driving on Highway 94, we can probably get to 4 hours. We can probably get to North Dakota already, passing the Red River, I suppose. So 4 hours, and then you take an exit. You're traveling slowly because you're probably looking for road signs or following your GPS. 25 miles per hour on a local road for 1 hour. Okay, so you're just wandering, trying to find your destination. So, okay, for 1 hour. And the question is average speed. Okay, so since you're given two different speeds, there is a natural, intuition that some students will take, let's average these two speeds. So let's just do that. So 50 plus 25 divided by 2, that is 75 over 2, 37.5 miles per hour. So is that the average speed? Because you just average the speeds. Is that the average speed then? Well, sounds like so, but it's not, because according to our definition, you need to have this. Let's see where that is. The total displacement and the total time, duration from one to the next, right? So the total displacement is not really given, but you can calculate it, right? 50 miles per hour for 4 hours, that's 200 miles. 25 miles per hour for 1 hour, that's 25 miles. So you add that 25 to the 200, you have 225 miles of total travel distance. And then what about total time? It's actually 4 hours plus 1 hour, right? You spent 5 hours together. So the 225 divided by 5. So this is how to calculate the average velocity. Total distance over total time in this case. So the total distance is 50 miles per hour times 4 hours, and then 25 miles per hour times 1 hour, and divided by the total time, 4 hours plus 1 hour. Right, so this is 225 to 225 over 5. Yeah, I made up the numbers to make it easier, so I just divide 4, 20, 25, 5, 45 miles per hour. Okay, so to compare this with this 37.5, you can see that in this case you just took an average between the two velocities. Despite the fact that you spend more time, you travel more distance at this velocity than the other, so how can you just weigh them the same, just average the two, right? So if you travel most of the time at this velocity, your average velocity should be pretty close to 50, right? So that shows because you travel 4 hours at this velocity and only 1 hour at this velocity, so the average tends to be pretty close to the higher velocity, or the velocity you traveled the most time at, right? The 50 miles per hour. The answer is the 45. Okay, so let's finally move on to acceleration. Acceleration is A, and the unit is meters per second per second. So let's talk about the units first. We can understand this as meters per second and then per second. So I can put another set of parentheses in a different color. So first you do this and then you do that. So meters per second, that is velocity. So velocity over time is actually, it means change of velocity over time. Remember, the change in position is also the same as a positions unit, right? So this velocity unit is actually the change of velocity over time. So if you're changing velocity over time, you're accelerating, or you can say you're decelerating or negatively accelerating. In either case, you're changing velocity with time, so you could have acceleration. So let's look at the definition here. Maybe move everything down about half of a line. Okay. So the definition of A average is equal to V2 minus V1. So this is a change of velocity between two velocities. They must have happened at two different times. So you were traveling at V2 at time t2, you're traveling at V1 at time t1. So you change your velocity by this amount, and then it took you this duration of time to make the change. So if you change the greatest and spend the least amount of time, that will be the greatest amount of acceleration, right? You could also be doing negative velocity, or you're reducing your velocity. Say the V2 will be less than V1, and then the overall acceleration will be negative. Okay. So let's do an example just like we had before. So we'll have V1 equals 5, V2 equals 15, and T1 equals 0, T2 equals 2. So let's calculate the average acceleration. So average acceleration, let's keep that average. That should be V2 minus V1, so 15 minus 5 over T2 minus T1, so 2 minus 0. So we just happen to have gotten a 0 as T1. So we have a 10 over 2, so we have 5 meters per second, right? I had both parentheses. So what this means is you are increasing your velocity over time, right? And how fast are you increasing it? You're increasing 5 meters per second every second. So it took 2 seconds to increase the 10 meters per second. And that's why you got a 15 out of the 5 after 2 seconds. Okay, so what if we had this was one object which was accelerating, and then there's another object that's decelerating or accelerating at a negative rate. So they could have started together. V1. Now let's move that down. Okay, V1 is equal to 5. V2 is equal to 0. Oh. So let's just imagine that we have maybe air track labs where we're hitting a light object with a heavy object. So at one moment they were almost traveling at the same speed, and then one slows down, the other speeds up, whatever they're doing here. So we'll have the same exact time duration for that second object to slow down. So the average acceleration of the second object is 0 minus 5 and divided by the same time duration, 2 minus 0. So minus 5 over 2, or minus 2.5 meters per second. I don't have to have the extra parentheses, but they help because this tells you this object, unlike the other object, is actually decreasing velocity at 2.5 meters per second every second. So given 2 seconds, it will decrease its velocity from whatever it had to 5 meters per second less. Well, it had 5, so it becomes 0. If this acceleration keeps on going another second, the velocity will be decreased by another 2.5 meters per second on top of the this velocity. So the object will start traveling at negative 2.5 meters per second. That means going backward along the this axis. Thank you.